In this tutorial, we are going to learn about energy transfer in a piston cylinder device with an electric paddle wheel operation. Please read the example question before you follow this video tutorial. Air at 400 kPa and 17 degrees Celsius is contained in a piston cylinder device. Electric work-in of 75 kilojoules per kilogram is transferring to air by a paddle wheel. During this process, heat is transferred to the air and the volume of air becomes 3 times. However, air temperature remains constant. Let's summarize the given information. First, we have initial temperature and pressure, and there is a heat transfer. Therefore, the volume of the air becomes 3 times of initial volume. Final temperature is same as initial temperature. In order to find heat transfer, we start with energy balance and energy transfer equation from the first law of thermodynamics. Using the given information, we can confirm it is a closed system, therefore no energy transfer by mass flow. It is also a stationary system, so there are no kinetic and potential energy changes. Most importantly, there is no temperature change during this process, so there is no internal energy change. When we apply all information to the energy balance equation, only remaining terms are heat transfer and work transfer. So we can find heat transfer per unit mass, this during process, by work out minus work in per unit mass. Work in process is only by the paddle wheel in the system, and the amount of the work in is given as 75 kilojoules per kilogram. Work out for this problem is a moving boundary work in the motion of the piston, so we can calculate the moving boundary work by pressure times the volume change. Air is the system, therefore pressure can be written by gas constant times temperature over specific volume using the ideal gas equation. Since gas constant and temperatures are constant values, integration of 1 over specific volume becomes natural log, as you can see it. From the given property information, we can plug it in the values into the equation, and then we can get the boundary work out of 91.48 kilojoules per kilogram. Finally, work out minus work in per unit mass is a positive value of 16.48 kilojoules per kilogram. Therefore, we can conclude there is a heat transfer in process in this piston cylinder device.